A very warm welcome, everyone. A very important article was there in yesterday's The Hindu regarding the Indian monsoons. इस अकेले आर्टिकल में आपकी ऑलमोस्ट सारे मेन कॉन्सेप्ट्स ज्योग्राफी के रिवाइज हो जाते हैं. इट बिकम्स वेरी इंपॉर्टेंट टू अंडरस्टैंड ईच एंड एवरी लाइन ऑफ दिस आर्टिकल एंड टुडेज वीडियो विल बी फोकसिंग ऑन दिस ओनली. I'll be walking through this entire article and I'll be explaining every interrelated concept and every point that has been mentioned in this editorial, and I will also explain whatever concept is the main concept behind it, right? So let's start with this article, one of the most important articles as far as geography is concerned for UPSC, right? So first of all, let me develop the base for this video. Why does UPSC asks questions on the monsoons? Because it is the prime factor that drives the Indian economy. Everything is dependent upon the monsoonal rainfall, right? So it becomes essentially important for a UPSC aspirant to be aware about the different factors which influence the Indian monsoons. This particular article in yesterday's The Hindu is talking about the effect of cyclones on the onset of monsoons. Although it is talking about just cyclones, but many concepts are interrelated and they have been discussed in that, right? So I'll be walking through this article and let's begin. So first of all, the title of the article says cyclones effects on monsoons onset. Onset means arrival of monsoons. How do the cyclones impact the advent, or you can say the arrival of monsoons? Over here, this article is talking about tropical cyclones. It is not talking about temperate cyclones, although a reference has been made to temperate cyclones as well. I'll be telling you what is the role of temperate cyclones as well. Although the prime domain of this article is with your tropical cyclones, right? It starts global warming's effects on cyclogenesis. What is cyclogenesis? Genesis means the birth of something. Cyclogenesis refers to the birth of tropical cyclones. When we talk about the birth of temperate cyclones, it is called frontogenesis, because temperate cyclones are formed because of the formation of fronts: warm front, cold front, occluded front, right? So just one more word with respect to this genesis word. We heard a word bombogenesis as well. It was associated with bomb cyclones. What are bomb cyclones? Aggravated temperate cyclones, right? So three words: cyclogenesis for tropical cyclones, frontogenesis for temperate cyclones, and accelerated or aggravated temperate cyclones are called bomb cyclones. For them we use the word bombogenesis. So they symbolize the initiation of cyclones. Global warming's effects on cyclogenesis. So they are talking about the effect of global warming on the birth of cyclones. We'll develop this concept as we progress. Over the Pacific and North Indian Oceans, right? The two oceans that this article talks about is the Pacific and the North Indian Oceans. Why? We'll come to that. The warming over the North Indian Ocean and the late pre-monsoon cyclones. Basically, when you talk about the warming of the North Indian Ocean, we are concerned with the Indian Ocean dipole. We'll be coming to this, how the effect of the positive Indian Ocean dipole was supposed to play a positive effect, what changes have been brought because of this cyclone Biparjoy. We'll be discussing all of that. The late pre-monsoon cyclones. Basically, this cyclone Biparjoy is a little late. Like Mocha arrived earlier, but in the Bay of Bengal, that was somewhat, you can say, a normal time for tropical cyclones to arrive in the North Indian Ocean. But Biparjoy is a little late. Why is it a little late? We'll be coming to that shortly, right? So this is the point which it is referring to, the late pre-monsoonal cyclones. And typhoons. Typhoons are simply your tropical cyclones that come near China, right, in your, you can say, western part of the central Pacific Ocean, right, are another monkey wrench in the monsoon's dynamic. Monkey wrench, they're simply using a fancy word to say there are different factors which control the monsoons. Multiple factors control the monsoons, their advent, the amount of rainfall, the, you can say, when will it, how far it will advance, how fast it will advance, how fast it will retreat, when will it retreat, how much rainfall it will cause. There are tens of factors that play a role. This effect of advent of cyclones plays yet another critical factor. That is the meaning that they're trying to convey by using this phrase monkey wrench, right? Wrench is that tool in the monsoon dynamics and the predictions of the monsoon's onset and its evolution through the season. It is important to predict the monsoons. Why is it important to predict the monsoons? Because your agricultural cycle depends on it. Once the IMD sets out the forecast, it mentioned, okay, on this date the monsoons are due to arrive. Your rice planting season will coincide with this only, particularly in your area north of the Tropic of Cancer. Basically, your rice cultivation, kharif crop season begins with the advent of monsoons, right? So that is why it becomes important to understand the factors controlling the advent of monsoon itself, right? How this cyclone played a critical role, and eventually the evolution through the season, how the rainfall will eventually evolve, how will they spread, when will they reach which part of the country, right? So all of that becomes important, right? So let's start with the article, right? The impact of global warming on the monsoons are manifested on its onset, withdrawal, seasonal total rainfall and extreme. So first of all, let's understand what are we talking about the impact of global warming. The first line states that we are concerned with the impact of global warming on the monsoons, and it is manifest on certain parameters: the onset, when it arrives, withdrawal, the retreating monsoon, and the total rainfall. How is global warming playing a role over here? Had you been following my videos, we have already covered this in thorough detail. I'll just give you a short overview, right? The earth follows a cycle. The earth follows a cycle of, you can say, 40 warm years, 40 cold years. Basically, it depends upon the strength of your AMOC. AMOC is your Atlantic Meridional Overturning Circulation. It is basically the thermohaline circulation, your oceanic conveyor belts, your ocean currents. After a cycle of 40 years, they tend to weaken. After a span of next 40 years, they tend to strengthen. In the year 2000, we entered a phase known as your, you can say, positive phase, or simply saying the warm phase. This chart represents your AMO index, your Atlantic multi-decadal oscillation. This represents your Pacific decadal oscillation, your oceanic oscillations in the North Pacific, and this is your Central and South Pacific, El Nino and La Nina chart. We'll be coming to this. I'll be drawing the interrelations. For now, the first line, impact of global warming, it needs to be understood. The present global warming is not just a result of man-made factors. Yes, man-made factors have aggravated the cycle. The peak that should have arrived after some time is nearer. It has not yet arrived, it is nearer the peak of the warm temperatures, right? So the next coming few years are going to be even warmer, right? I'll just give you a brief overview about the factors that have contributed to global warming this year. First of all is your weakening ocean currents. In the year 2000, the earth entered that stage of your weak AMOC. The oceanic circulation weakened. The ocean water circulates. The surface warm water approaches near the poles, where upon freezing the salt is precipitated. It generates a downwelling force near the polar areas, which drives the ocean bottom cold ocean currents, right? These strong underwater currents, they basically eventually lead to the upwelling of cold water in, you can say, areas where you experience these offshore winds, Like for example, wherever we experience the formation of cold ocean currents, it is usually in the form of the offshore winds. Like this is the zone of your, you can say, trade winds over here, southeast trade winds over Africa, over the Namibian part. These winds are offshore. The warm water is pushed away by the surface winds, which adds another pull factor for the cold water to rise to the surface, right? This helps to circulate all the water on earth. But after this span of 40 years, this oceanic conveyor belt weakens. I'll not go into further details for this. In case you want to understand it in detail, I'll add a link in the description box. I'll just pick this concept from here. So since the year 2000, the oceanic conveyor belt is the weakest, because of which the surface water is not being recirculated that much, which is why we are experiencing a peak in all these, you can say, cycles in every ocean. Every ocean has its own cycles. Your Atlantic multi-decadal oscillation, Indian Ocean dipole, El Nino, La Nina, Pacific decadal oscillation, they are all peaking at the same time. Meaning thereby, when warm water will remain near the surface, actually because water is being forced to remain near the surface, it is not being recirculated, it is gaining more heat from the atmosphere, from the sun. Warm water will evaporate more, it will pump in more moisture into the air. After 27 degrees in water, convection currents start to rise. More water vapor in the atmosphere results in more greenhouse gases. They will absorb more heat. So basically, nature itself is pumping in a lot of greenhouse gases. Add to that a few more things. We recently experienced the end of a triple dip La Nina. What is a triple dip La Nina? It simply means that for 3 consecutive years, we experienced La Nina conditions. What is a dip? A positive chart represents a higher temperature. It is basically a El Nino. Your colder temperature represents a dip in the chart. That is why it is called a triple dip La Nina. When we talk about El Nino, La Nina, we are concerned with this central band of the Pacific Ocean, which extends from the East Pacific to the Central Pacific. If this is warm, it is El Nino. If this is cold, it is La Nina. For the past 3 years, we experienced La Nina. Cold water was concentrated over here. Warm water was pooled up along the east coast of Australia. Also, in North Pacific, we observed the negative Pacific decadal oscillation. All the warm water was concentrated in the central North Pacific Ocean, again pumping in excess heat into the atmosphere, leading to multiple cyclones, which is why at present as well, we are experiencing all these. This is today's forecast. This is today's screenshot. It is not just one. You can say 5 tropical cyclones are present at this time in this area, right? We'll come to this, right? So basically, human-made factors are also playing a role, but nature is also playing a role. Just one more point. We experienced the underwater volcanic eruption in Tonga. Basically, it also added 10% of the water vapor into the atmosphere. Like if X amount of water vapor exists in the atmosphere, this volcanic eruption alone added 10% of that X amount into the atmosphere, right? So a lot of greenhouse gases have been emitted by nature itself, water vapor, right? What is the impact of global warming on the onset of monsoons? How does it affect the arrival of monsoons? Let's come to this point first. We have established the first point, that the ocean currents are the weakest at this particular point of time. This red symbolizes all the warm water pooled up on the surface of the earth. Because of the excessive warm oceans, let's consider the fact that the greater the difference between the temperature of land and water, the greater will be the meandering of the polar jet stream. Why? Because the polar jet stream will always flow between the barrier of cold and warm air. Because of excessive warm waters in all the oceans extended towards their limits, the jet stream is forced to meander further. In winters, this gradient will be higher because the land is liberal. It will cool faster because it has a lesser amount of specific heat. Simply speaking, thereby heat does not travel deeper into land. All that heat is concentrated near the surface, because of which it will heat up faster, whereas the water will absorb heat to a greater depth, because of which the same amount of heat is distributed over a longer area. So water takes more time to heat up, it takes more time to cool down, because of which during winters the contrast between the air temperature over land and water will be very different, high contrast. The jet stream, the polar jet stream will meander even more. The higher the meandering, the more severe the temperate cyclones. Western disturbances are temperate cyclones. This year we experienced prolonged western disturbances. In fact, they are still continuing. They are still continuing. A few days back, North India experienced a series of thunderstorms. They were basically you can say the warm front basically was obstructed. The passing warm front of a temperate cyclone was obstructed by the Himalayas. All that moisture concentrated along the foothills. It led to the formation of thunderstorms, and we received heavy rainfall in the form of thunderstorms, right? It was not because of your monsoons, but because of your western disturbances. What is the impact? How is it affecting the onset of monsoons? Global warming, warmer oceans, more meandering, severe temperate cyclones, western disturbances. Before the advent of monsoons, we need the landmass to heat up. We need the Tibetan plateau to heat up to generate a strong surface low pressure. A low pressure will attract wind towards it, but because of this constant arrival of western disturbances, the landmass was not able to heat that much. Constant cloud cover because of your warm fronts of the temperate cyclones. Constant rainfall reduced the temperature of the land, which weakened the first initial factor of the generation of strong low pressure conditions over North India and Tibetan Plateau. The first factor was weakened because of global warming affecting the onset of monsoons. There are many factors. One prime factor is the pull factor generated by the low pressure conditions created over North India and Tibetan Plateau. This has not matured to that extent, right? I'll be picking this concept afterwards now. Withdrawal of monsoons. How does it affect the withdrawal? So basically, when we talk about monsoons, let me go one step further now. When we talk about the monsoons, we are primarily concerned with the ITCZ. What is the ITCZ? The Intertropical Convergence Zone. What is that? Basically, the area where the actual trade winds converge. They will converge on the area of your highest point of low pressure. Basically, when we draw the pressure belts, we draw it in an equinox position. This is the normal diagram for your pressure belts. This symbolizes your basic equinox position when the sun is directly overhead the equator. But we all know that the monsoons arrive in summer, meaning thereby when the sun enters the northern hemisphere, along with the motion of the sun, the area which is directly being heated by the sun is also shifting northwards. That excessive heated area will form the strongest low pressure area. That low pressure area will be the result of converging trade winds. So this belt known as the ITCZ is constantly shifting. It is constantly shifting northwards along with the march of the sun. It is no coincidence that all these tropical cyclones are formed in a straight line. Basically, they coincide with the ITCZ, right? So now coming to this point, I was coming to explain withdrawal. What is the monsoon trough? You will hear this word time and again, monsoon trough. Monsoon trough is nothing but this area of low pressure belt known as your ITCZ. Now the interesting fact is, the upward limit of the sun is your Tropic of Cancer. It cannot move beyond that because of the position of the earth, right? If the northern hemisphere is presently inclined towards the sun, that is why we are experiencing summers. The direct vertical rays of the sun will be confined to the Tropic of Cancer. But in India, during the monsoon season, the ITCZ shifts to around 30 degrees north beyond the Tropic of Cancer. This low pressure area is called the monsoon trough. How does it go beyond that? Ultimately, this is an area of strong low pressure. This ITCZ is an area of strong low pressure. What happens is, during this time, pay attention. India most of the time is under the impact of your subtropical high pressure belt. Almost the entire northern part of India is under the impact of the subtropical high pressure belt. Air is sinking. Air is sinking over this entire belt. What happens when air sinks? Sinking air will lead to certain phenomena. The first one is your adiabatic heating. All the heat is now concentrated near the surface. Constant sinking of air will lead to a heating effect. No heat is being added. Air is being compressed. The same amount of heat is now concentrated in a smaller area. It is subjected to a larger amount of pressure. So, sinking air will heat up. The air in the atmosphere itself was very warm. Upon sinking, it is heating up even further. But the thing is, we need to just draw this parallel. I'll just explain this concept in brief. Unless and until this high pressure belt shifts northwards, we cannot experience strong monsoons, right? Why? I'll just try to explain it shortly. So, the point that I'm trying to make is, we need low temperature, low pressure conditions over the northern part of India to generate that pull factor, that low pressure. When India is subjected to this situation of the high pressure belt, no convection currents can rise. Because no convection currents can arise, no cloud formation can take place. So, till India is under the impact of the subtropical high pressure belt, we receive abundant sunlight. This is the normal situation. The landmass starts to heat up, not just because of the, you can say, sunlight, no clouds in a high pressure region. Clear sunlight, it heats up the land. The sinking air further heats the land. It generates prime conditions to generate the pull factor for the monsoon winds. Eventually, as the sun moves to the Tropic of Cancer, this high pressure belt also shifts northwards. As soon as this high pressure belt shifts northwards, the landmass, the entire northern part of India and the Tibetan plateau, it has heated sufficiently. As soon as this high pressure belt withdraws, convection currents are allowed to generate. Once convection currents will be allowed to generate, it will generate that convergent wind system, strong low pressure conditions, right? Because of this heating of the northern hemisphere, northern part of India, because of this heating of the northern part of India, what happens is, in effect, the ITCZ is limited to the Tropic of Cancer. This is the present position right now. Sun is approaching the summer solstice. So, the ITCZ is somewhat coinciding with the Tropic of Cancer. But I did mention the ITCZ moves to 30 degrees north. Why? Because of this additional heating of the northern part of India and the Tibetan plateau, the net region of warm air shifts northwards. So, which is why the monsoonal trough, this central low pressure region, moves to your 30-degree latitudes along the foothill region. This is basically your onset of monsoons. This monsoonal trough will eventually lead to the winds to converge to this extent. Naturally, the stronger and higher this trough moves, it will reach to greater extent. The higher the temperature of the land, the greater the extent of the ITCZ during the monsoons. So the point that I'm trying to make is, if the landmass is not that warm, this monsoonal trough will not go further northward. Why? Because eventually, what is the retreat of the Indian monsoon? As the sun again moves southwards, the area which is constantly being heated is also moving southwards. Along with it, that area of low pressure is also moving downwards. But the ITCZ had already shifted to a little higher extent because of the excessive heating. So what is the retreat of monsoon? Basically, this area of low pressure constantly starts moving back. Once it starts moving back, because now the dominant heated region is moving southwards. Low pressure is a convergent wind system. It starts attracting winds from both sides, basically. The dominant direction being in basically from your northwest. So that is why your retreat of monsoon is also governed by global warming. Why? The higher the temperature of the land, the greater will be the extent of monsoonal trough. The greater will be the extent of the monsoonal trough, the greater will be the time for which it spends on India. जितना monsoonal trough ऊपर जाएगा उतना ही ज़्यादा retreat भी करेगा naturally. Now the thing is, I have told you that ideally global warming should lead to a higher extent of the north ITCZ, but that is not the case. Because, can you see these comma shaped objects? They are your temperate cyclones. They are also moving. Just observe how close they are. Temperate cyclones, tropical cyclones, very nearby. This is a tropical cyclone. They're all tropical cyclones. These comma shaped objects, they are your temperate cyclones, still ongoing. What happened in India this time? I did mention it just now. The temperate cyclones kept on adding rainfall in the northern hemisphere. It did not allow the landmass to heat sufficiently, because of which the monsoonal trough has not been able to move further. If it is not moving further northward, naturally it will retreat from a lower area. Are you able to understand this point? So that is the how the interlinkage is drawn. Manifestation is the ground reality implementation part of the impact of global warming on the onset, withdrawal and total seasonal rainfall. Total seasonal rainfall will depend upon a number of factors. The first one being the actual extent of time. If it is not extending to greater you can say heights, your greater latitudes, you will receive lesser rainfall. Also, what is the role of global warming in your total rainfall? Primarily when we talk about the Indian monsoons, we are concerned with this particular area of the Indian Ocean, your northwestern part of the Indian Ocean. If the temperature over here in the water is warm, what will be the result? Warm water will lead to more evaporation. More evaporation means more moisture in this air mass. The monsoon winds generating from the mascarene high, the southeast trade winds enter the northern hemisphere under the effect of Coriolis, deflected to the right. They push this air mass over India. This air mass governs the amount of precipitation on India during the monsoons. The monsoonal trough will be governed by the pressure conditions over North India. If it generates a strong low pressure, these winds will be faster. These stronger winds will be able to push this moist air mass over the Indian subcontinent in a better way, right? So basically, whenever we talk about total monsoon, we are concerned with the moisture present in this area, which is where Biparjoy's role comes. Biparjoy is depleting the moisture in this particular area, right? Since we are on this slide, I'll just mention this point. When the warm water is concentrated in your, you can say, western and north Indian Ocean, it is known as the positive Indian Ocean dipole. When the warm water is concentrated in the eastern part, it is known as a negative Indian Ocean dipole. A positive Indian Ocean dipole is good for us. In 2019, we experienced the strongest ever Indian Ocean dipole, meaning thereby warmest waters. In fact, in the world right now, the warmest waters are present in the Indian Ocean only, in this particular area, which is why we are experiencing a continuous series of tropical cyclones in this area only, right? Moving ahead, I'll come back to the points, don't worry. Global warming also affects the cyclones over Indian Ocean and typhoons over northwestern Pacific Ocean, right? Definitely. As I told you about these cycles, we just experienced a triple dip La Nina, a negative PDO. So the warm water was pooled up for the last 3 years at least in this area only, which is why all of that warm water has led to the formation of a series of tropical cyclones, right? We are seeing cyclone formations in the pre-monsoon cyclone season, closer to the monsoon onset, arguably due to the influence of warmer Arctic Ocean on the winds over the Arabian Sea. So the word that the author is trying to, the point that the author is trying to make is regarding the Arctic teleconnection. I've already made a detailed video on the Arctic teleconnection. I'll just give you a brief. The author is basically trying to point out to the Arctic teleconnection. The Indian and Norwegian scientists, they began a study in 2014, and recently a report has been published that if the temperature in the Arctic Ocean is warm, we receive better monsoons. If the temperature in the Arctic Ocean is cold, we receive poor monsoons. Why has the author written arguably? Because in this study, they are yet to mention the actual causing factors. But I will mention you two important factors that are generally at play. First of all, whenever this warm water is able to reach to the polar areas, it means that the oceanic conveyor belt is at the weakest. Whenever the oceanic conveyor belt is at the weakest, meaning thereby the surface water is not circulating that much. Whenever that is the case, we will observe warm surface water being pulled up all along the surface of the oceans, which is why the air masses have maximum amount of moisture in the air, right? So that is the first interrelation that you can draw. The second one is, the greater the extent of warm water, the more will be the meandering of jet stream. The more the meandering in jet stream, the severe the temperate cyclones. The more severe the temperate cyclones, the greater will be the impact on the Indian landmass, right? It is not a coincidence that we experienced the Himalayan tsunami in 2013 in Uttarakhand. Three factors were at play. One was, it occurred on 17th of June. Basically, that was the time when the monsoons also arrived in Uttarakhand. Also, a passing temperate cyclone in June that year in 2013, it was able to provide additional water. And third was the breach of the Chorabari glacial lake, right? So just telling you, it started in 2000, in the year 2000, right? So basically, if you want more details on the Arctic teleconnection, you can watch that video, right? The monsoon is of course affected by the tropical oceans, Indian, Atlantic and Pacific. The atmospheric bridge from the Arctic and the oceanic tunnel. So basically, when you talk about these atmospheric bridge, we are basically concerned with the circulations, the different cells that are generated. Like we studied during El Nino, La Nina, atmospheric circulations. These are basically called teleconnections. TELE, just like television, we have teleconnections. If some physical phenomena occurs in a particular area, it will have an effect on some isolated area away from that point, connected by atmospheric connections, basically your different cells. So these atmospheric bridges that the author is using, it is used to symbolize these teleconnections, right? And the oceanic tunnel which he's talking about is your ocean currents, your weakening ocean currents, right? How does the position of cyclone matter, right? I'll just tell you a brief about this. So first of all, I'll just tell you about, there is a very common doubt among students about the rotation of cyclones. How do the cyclones rotate anti-clockwise in the northern hemisphere? I'll give you the brief. Low pressure system, we're talking about the northern hemisphere only. A low pressure system is a convergent wind system. Winds are converging towards it. The northern hemisphere experiences a Coriolis effect which deflects the winds to the right. So all the winds which are converging towards this low pressure area tend to deflect to their right. Now you have to observe this thing. This is the air in that central low pressure region. Winds are converging towards it, but they are deflected to the right. They are converging towards the central low pressure, converging to the right. Again converging to the central low pressure system, deflecting to the right. So the net resultant motion created in this air focused in this low pressure region is a anti-clockwise motion, right? Similarly, if you want to understand the case for a high pressure system, it is a divergent wind system, again deflection to the right in the northern hemisphere. The net resultant motion generated is in a clockwise fashion. Every strong low pressure system is called a cyclone. Every strong high pressure system is called an anticyclone. Now this information is about to come in handy as you proceed further into the article, right? So the point that the author was trying to make was the impact of cyclones, the position of cyclones. Let's take the case of Mocha. Yes, let's take the case of Mocha. How does the author try to relate the position of a cyclone with the effect on the Indian monsoons? Recently, we experienced a cyclone in the Bay of Bengal as well, which was called Mocha. This was its trajectory. Now, the thing we need to understand is, in order to get better monsoons, what are monsoons basically? The winds are basically, the southeast trade winds enter the northern hemisphere as southwest trade winds. If a cyclone is formed in the Bay of Bengal, just like Mocha, this strong pull which is being generated by this cyclone, it helps the advent of winds in this direction. So it will help to pull winds over the Indian subcontinent, right? So, but if it is present in the Arabian Sea region, like we observed during your present situation, Biparjoy has formed over the you can say Arabian Sea region. Basically, it is also pulling wind, but it is not allowing the winds to enter the Indian subcontinent. It is pulling the winds away from the Indian subcontinent, right? The, you can say, cyclone Mocha, it helped pull the winds over the Indian subcontinent, but this cyclone Biparjoy over the Arabian Sea, it is not allowing the winds to enter the Indian subcontinent. It is just pulling the winds away from it. Similarly, a series of cyclones were formed over the, you can say, Western Pacific as well. These cyclones also pulled all this air mass towards themselves. They have led to the late advance of the Indian monsoons because all this moisture laden air mass was pulled towards these strong cyclones, right? I'll come to this, right? Some cyclones in the North Indian Ocean have both positive and negative effect. Just like I told you, depending upon their position, if they are assisting in the pull factor of these winds over the Indian landmass, they are generating a positive impact. However, if they are pulling the winds away from the Indian landmass, they will cause a negative impact, right? Now, the next most important point that the author has mentioned is The Bay of Bengal had Cyclone Mocha in the first half of May. It briefly intensified into a super cyclone. The scale used to measure tropical cyclones is the Saffir-Simpson scale, right? Just an additional point. Before it weakened rapidly upon landfall. What is landfall? When the eye of the cyclone moves on land. Once the eye of the cyclone moves on land, this process is called a landfall, and its heat source is cut. As soon as the heat source of the cyclone is cut, it slowly starts to dissipate, right? Mocha's northwest to east trajectory. Why is it saying northwest to east trajectory? Basically, this is Mocha. Initially, it was moving in a north towards the northwest. Later on, it deflected towards the northeast. So basically, this is the direction that has been mentioned in the article. Northwest to east trajectory over the Bay of Bengal was a result of unusual anticyclones. It was a result of unusual anticyclones that have been parked over the Arabian Sea and Bay of Bengal since March. Very important point to understand. Very important point to understand. Let's come back to the pressure belts. Let's come back to the pressure belts. Even the northern part of the Arabian Sea and Bay of Bengal are under the influence of the subtropical high pressure belt. The sinking air generates a strong high pressure on the surface. What is the effect of this? These strong high pressure regions on the surface are known as your anticyclones, like I just mentioned. Sinking air in a high pressure belt region, all that sinking air creates a high pressure on the surface, that is the pressure belt. It leads to the creation of strong anticyclones. Why stronger? Because the air itself which was falling is warm. Upon falling, it heated even further. Stronger divergent wind systems, stronger anticyclones. How did they play a role? How did they play a role? They warmed the waters of the Bay of Bengal region and your Arabian Sea region. Why? Because the greater the high pressure created, the more the convection currents will be prevented. No convection currents can rise in a high pressure belt. If no convection currents can rise, there will be clear skies. Clear skies means more sunlight. More sunlight means more heating. So, these unusual anticyclones is referring to the impact of the high pressure belt leading to clear skies. Clear skies led to more insolation, more heating of the North Indian Ocean, basically a northernmost part of your Arabian Sea, and your Bay of Bengal, basically more primarily on Arabian Sea. This warm water circulates in from, it keeps oscillating under the effect of your oceanic currents. Your north equatorial current moves from west to east during summers and from east to west during winters because of the change in wind system, right? Alright, so this is referring to the impact of the high pressure belt leading to warmer waters, right? Mocha dissipated on 15th of May. The back winds helped the monsoon set in on time over the Andaman and Nicobar on 15th of May. The normal time of arrival of monsoons on the Andaman and Nicobar Islands is 15th of May. The cyclone generated in the Bay of Bengal, Mocha, when it moved northwards near 15th of May, these strong winds which were being pulled towards it, it led to the advancement of the low pressure region. It moved the monsoonal trough closer to the Bay of Bengal, and eventually it was able to cause rainfall on the Andaman and Nicobar Islands on 15th of May, which is a normal time of advent of monsoons. But this rainfall, the role that the author is trying to say is the strong convergence created by this cyclone eventually helped to pull the moisture, the moist monsoonal air mass over the Andaman and Nicobar region, right? One severe consequence of the anomalous anticyclones since March is that both the Arabian Sea and Bay of Bengal have warmed by more than 1 degree. Now this line becomes clear because of this strong anticyclones. No cloud cover led to more sunlight. More sunlight led to more heating. Also, the sinking air was heating up. The air itself was warm. Upon sinking up, it heated even further. All this warm air eventually, when coupled with the intense heating by the sun, it raised the temperature of the Arabian Sea and Bay of Bengal, leading to the formation of more cyclones. Right? Biparjoy is not interacting much with the monsoon trough at this time. However, its late birth as well as late onset of the monsoons are both closely related to the typhoons in Northwest Pacific. Let's understand this point now. First of all, why is it talking about the late onset, late birth of the you can say cyclone? Normally cyclones, Mocha appeared at the right time. Biparjoy is a little late. It should not have formed at this time. It should have formed earlier. What is the prime reason? It is a very important point to understand. Why did Biparjoy form only now and not earlier? The answer lies again in the first point that I had explained. Pay attention. Had the western disturbances not been that prolonged, had the western disturbances not caused rainfall over India so late, the landmass would have heated. Had the landmass heated properly, stronger convection would have arisen. The stronger convection would have led to the formation of upper air anticyclonic conditions. If there is a low pressure on the surface, convection currents will take place. It will hit the tropopause. It will create a divergent wind system. Upper air high pressure system, it is called your anticyclonic condition. This strong anticyclonic condition in the upper atmosphere over North India and the Tibetan Plateau is essential to the formation of your subtropical easterly jet stream. Had the western disturbances not reduced the temperature of the northern part of India and the Tibetan Plateau, we would have experienced a stronger subtropical easterly jet stream. If the subtropical easterly jet stream was properly established over the Indian subcontinent at this point of time, Biparjoy would never have formed. Why? In order for a tropical cyclone to form, we need a minimum vertical wind shear. What is a vertical wind shear? The surface wind and the upper atmosphere winds, they must not flow in different way and at different speeds. Why? In order for a cyclone to form, we need strong convection currents and we need the vertical ascent of air in one area. If the subtropical easterly jet stream would have developed over the Arabian Sea properly, we would have experienced stronger air circulation in the opposite direction, which would have not let this cyclone to mature. Since the western disturbances cooled the northern part of India and the Tibetan Plateau, lesser convection took place. The anticyclone formed over the North India and Tibetan Plateau region in the upper atmosphere was very weak, not able to generate that, you can say, easterly jet stream, because of which no vertical wind shear was present over the Arabian Sea, which is why, although it should have been present, since it is not present, this cyclone was allowed to generate. On the contrary, because of severe cyclones taking place near Philippines, they are also generating the same system. Now just observe this wind system. These are the map of your jet streams. The present map of your jet streams. What is going on over here? Because of strong cyclones in the western central Pacific right now, naturally low pressure system near the surface, upper air divergence, strong upper air high pressure areas are created, stronger anticyclones are being generated. So although this easterly jet stream is developed, this is your easterly jet stream which is being developed, but the thing is, its domain is further to the east. It should have been towards a little west over the Arabian Sea, so that this cycle would have assisted the southwest monsoons. Basically, the role of this subtropical easterly jet stream is it rises from the northern part of India and eventually it intensifies this cell. Basically, this is the Hadley cell of the southern hemisphere, surface southeast trade winds, convection, and it sinks. What is the monsoon? It is basically the extension of this Hadley cell of the southern hemisphere. These southeast trade winds, not southeast trade winds, the subtropical easterly jet stream, when it flows over the Indian subcontinent, it helps, you can say, aggravate this cell, which pushes the surface winds further. But now this upper air circulation is a little to the east of the Indian subcontinent because of stronger cyclones. And since the landmass is not that warm, this same system is not able to generate over India, which has led to the formation of the cyclone Biparjoy, right? Which has led to the late birth as well as the late onset of monsoons. While late onset of monsoons, lesser pull factor from the colder surface, this cyclone is basically pulling all the moisture towards it. All the winds which should have entered the Indian subcontinent are being funneled and rerouted towards this cyclone now. So basically it is not allowing that air mass to enter the Indian subcontinent, right? The next one was Mawar, was another super typhoon. It was formed in the Western Pacific Ocean, right? It was the strongest cyclone of 2023 till now. This is the path of Mawar. I just explained it to you. Even this cyclone caused the diversion of the surface winds towards itself. Because of this only, we are experiencing that the upper air circulation, this upper air subtropical easterly jet stream system is a little to the east. It should have been developed over the Indian subcontinent by now, but it has not. Next, these powerful typhoons are thirsty beasts and demand moisture from far and wide. Definitely, the birth of a tropical cyclone, the primary factor is warm waters. Wherever the warm waters will be present, they will form, and naturally, because of a triple dip La Nina and a negative PDO, all the warm water was pooled up in this particular area for the last 3 years at least, right? Which is why they have intensified so much. Mawar pulled winds across the equator. We have discussed this part. Southwesterly winds over the Arabian Sea are welcome news. They bring large quantities of moisture onto the Indian subcontinent. They are referring to that same thing that I have already explained. Monsoon is dependent upon this air mass. This moisture laden air should enter the Indian subcontinent at a relatively quick pace. If they are slower, we will receive poorer or less rainfall. If it moves quickly, we will receive better rainfall, which is why the impact of El Nino and La Nina is important. What is the mascarene high? Yes, what is the mascarene high? The area of the subtropical high pressure belt in the southern hemisphere in the South Indian Ocean is known as the mascarene high. Why mascarene high? Because there are 3 islands in this area: your Reunion Island, Rodriguez and Mauritius. Collectively, these 3 islands are called mascarene islands. Based upon that, they are known as the mascarene high. Why is it important? Winds originate from this area. They cross the equator, deflected to the right because of Coriolis. They enter the Indian subcontinent as southwest monsoons. These winds, the intensity and strength of these winds is playing a key role to push this moisture laden air mass over the Indian subcontinent, right? So Mawar pulled the winds across the equator. This cyclone which generated in the Western Pacific, it pulled this moisture laden air mass towards itself. Then Mocha depleted the moisture in the Bay of Bengal region, right? So Mawar deflected all this moisture laden air mass towards itself. It depleted all the moisture. Then Your Mocha, it deflected all this moisture toward itself, it depleted all the moisture. Now Biparjoy is doing the same thing, right? A present cyclone is also being formed, the tropical cyclone Gokul. Basically, this is the one they are talking about. It is also a very strong cyclone, right? Southwesterly winds over the Arabian Sea are a welcome news. Basically, southwesterly winds over the Arabian Sea, they are talking about these winds which are deflecting to the right in the northern hemisphere. They are welcome news because eventually they will come, they will move over the Indian subcontinent as southwesterlies, right? They bring large quantities of moisture. Definitely, they are pushing into that, pushing in that warm and moist air mass. On the other hand, the southwesterly winds over Bay of Bengal are bad news. Why are they saying that? This strong wind system usually is a little biased towards the Arabian Sea because it is eventually this air mass which is being pushed over India. Now, at present, this wind system, this southwesterly wind system is more focused in the Bay of Bengal area as compared to the Arabian Sea because of stronger cyclones, because of colder temperature of the surface in the North Indian part and the Tibetan region. The monsoon winds over the southern Bay of Bengal sweep in from the southwest and west. They turn around and head northwestward. Basically, what are they talking about? Your southeast trade winds enter the northern hemisphere as southwesterlies. They split and form two branches of the monsoons. One enters India as the Arabian Sea branch. The other one is deflected by the mountains. The Arakan Yoma mountain, Myanmar, and the syntaxial bend of India, basically the Himalayan mountain and the mountains of your northeast, they create a funnel. These moisture laden winds, the Bay of Bengal branch, which is moving earlier in a southwesterly fashion, they are deflected from this barrier of mountains and they move towards the northwest, right? This is the point that they have mentioned. They turn around and head northwestwards, right? Winds are southwesterly over the entire Bay of Bengal when Mawar was active, right? We've covered this point. Now, this last paragraph is basically trying to sum up that along between this entire complex system, the monsoonal winds are a very small part. What is the monsoonal wind system? It is basically that small moist air mass which wants to enter the Indian subcontinent with the assistance of these southeast trade winds entering the Indian subcontinent as southwesterlies. So these complex factors, they govern how and when it will enter India, how much moisture will it contain, right, and what will be its eventual impact on the Indian economy, right? So basically, this sums up all the important factors that were covered in this article. The last point that the author tries to make is the late monsoon does not necessarily indicate a monsoon deficit, right? The point here being, although there is a delay in the Indian monsoon, the monsoons entered Kerala on 9th of June. They should have entered Kerala by 1st of June. In the past 20 years, the Indian monsoons have not been this late. Prime factors: 1. Western disturbances lowered the temperature of the surface of the northern part of India. Weaker low pressure system created over North India. Weaker subtropical easterly jet stream. This cyclone pulled all the moisture towards itself, right? Prime factors which led to the late advent of monsoons, but it will not decide the overall moisture that will be precipitated on India. But although here I would like to differ with the author, this air mass has already been depleted of most of its moisture. This cyclone Biparjoy has utilized most of the heat and moisture present in this air mass. Once this moisture has been depleted in this air mass, the winds which will eventually push this air mass over the Indian subcontinent, which this air mass will basically have less moisture in it now. So we will definitely receive poorer monsoon this time. On top of that, El Nino conditions are developing. Basically, we are anticipating a full-fledged El Nino by July. we are anticipating a full-fledged El Nino by July, and this is the present situation. As you can see, this is your traditional, you can say, symbol for an El Nino, this stretch of warm water in the central Pacific from the East Pacific to the West Pacific, right? So it will mature by July. What is the impact of El Nino on the Indian monsoons? Strong low pressure conditions create the cell, your Walker cell is generated. It creates drought like conditions over Australia. Strong high pressure is created over in Australia. This high pressure is a divergent wind system. The Mascarene High itself is also a divergent wind system. We need a high pressure in this area. The high pressure created over Australia because of El Nino will create a low pressure in this area. Why? This is a strong divergent wind system on the surface. It will lead to, you can say, a low pressure region near the African mainland. The cell will be formed like this on the southern part of the Indian Ocean. So technically, a strong low pressure is created near Madagascar, which will weaken the Mascarene High. The winds which will eventually enter India will be weaker. Weaker winds and an air mass which has already been devoid of moisture, it will eventually lead to poorer monsoons, right? So basically, I just tried to sum up all the important concepts that were associated with the monsoons, right? I'll add the required links in the description box. So thank you so much and stay tuned for further information.